Good morning. Today I am going to explain expression for intensity of an electric field at any point on the perpendicular bisector of an electric dipole. This is one of the important topic in electrostatistics. So first of all we should know what is electric dipole and what is electric dipole moment. Okay, so what is electrostatistics? Electrostatistics is nothing but it's a branch of physics in which we are discussing about the charges which are at rest positions. Okay, so this is known as the electrostatistics. Now what is electric dipole? Electric dipole is nothing but a simple arrangement of two charges or by separated by a some distance. Here the minus q and plus q charges are separated by a some distance, that is 2l. The center of this two charges is O. The distance from O to plus q is L and O to minus q is L. The total distance is 2l. So what is electric dipole? Electric dipole is simply a arrangement of two charges with some distance or finite distance or a small distance is called the electric dipole. Now what is electric dipole moment? Electric dipole moment is nothing but it's a product of magnitude of one of the charge, any charge plus q or minus q, a product of one of the charge and the distance between the two charges, that is 2l. So that is called the electric dipole moment. Okay, so in the next topic we are going to talk about this electric dipole and the dipole moment also. So that's why we should know what is electric dipole and what is electric dipole moment. Okay, this is measuring in centimeters. Now come to the point here. Now I am going to find out the electric field at any point on the perpendicular bisector of an electric dipole. So bisector means that is divided into two parts. It means here let us consider an electric dipole with the center O and P be the any point on the perpendicular bisector at a distance of r from O. So this can be seen like this. Let us suppose AB is a electric dipole. Okay, so this is perpendicular bisector. Bisector means it's divided into two parts. That is, let us consider an electric dipole with center O. With center O and P be any point on this bisector. So P be any point on the perpendicular bisector at a distance of r from O. Okay, from O. Okay. Now here I wrote this r square plus l square to the power of half for this and r square plus l square to the power of half for AB, because we know that according to the Pythagoras formula, that is in any right triangle. Okay, so this triangle or this triangle, that is OBPB or OPA, for any right triangles the square of the hypotenuse is equal to the sum of the squares of the other two sides. So sum of the squares of the other two sides means two sides are OP is one side and OP is another side. So the sum of square of these two sides will be equal to the square of the hypotenuse, that is PB square. So according to that Pythagoras formula, I can write here OB whole square OP whole square is equal to PB whole square. So OB whole square is L. Okay, and OP whole square is nothing but a R square. So is equal to this one PB whole square I can write. So if you remove the whole square, then it can be written as in the form of 1 by 2. So R square root. Then PB can be written at L square plus R square to the power of half. So we got a value for the PB value is R square plus L square to the power of half. Similarly, we can do for the right triangle AOP. Then we will get R square plus L square to the power of half. So I wrote P is also L square or R square plus R square to the power of half. Okay. Now we are going to find out the intensity at a point P, which is a perpendicular bisector. Okay. Here let E1 be the intensity of electric field due to the plus Q charge. So here E1 be the intensity of electric field due to the plus Q charge. This plus Q charge, E1 is the intensity at a point P. Okay, so we know that intensity expression can be written as E1 is equal to Q by 4 pi epsilon naught R square. So R square is nothing but a here BP. due to the plus q charge. So that is BP. So BP whole square value is r square plus l square to the power of half. So we can write here BP whole square. So BP square value is already in the form of 1 by 2. So 1 by 2 to the power of square means 2 get cancelled. We will get only r square plus l square. Okay. So let us take equation number 1. Similarly, for E2 is the intensity of electric field due to minus q charge. So intensity of electric field E2, this one, E2 is the intensity of electric field due to the minus q charge at a point P, that is the perpendicular bisector on the dipole. So we know that we can write intensity expression E2 is equal to q by 4 pi epsilon naught. Here AB whole square. So AB whole square value is r square plus l square to the power of half to the power of square. Then we will get square means that is 2 get cancelled. We will get only r square plus l square. So AB position will be we will get r square plus l square. Let us take that is equation number 2. Now we have to calculate the resultant intensity. The resultant intensity of electric field E can be obtained by the law of parallelogram. So we can calculate this one by the law of parallelogram from the two similar triangles. So from the two similar triangles, that is E1P and APB. See, this one is one triangle and this one is one triangle. These two are similar triangles. So by that similar triangles, I can write by the property of similar triangles, EP by AB is equal to the E1P by PB. This is the property of similar triangles. So by that property, I can write PE by AB, that is PE by or PE by AB, and is equal to PE1 by, that is BP. Okay, BP. So this can be written as, if you take this PE value is equal to AB PE1 by BP. So P is one component and this is another component. We are replacing this PE as E and PE1 is as E1. Okay, here I wrote here PE is as E. This component is replaced by E for simplification only. PE1 is equal to E1, and we know that AB value is how much? AB value is equal to the 2L. I can write AB value is, here L plus L is 2L. So I can write. So here this can be written as E. This value PE is equal, PE is nothing but a E is equal to AB dot PE1 value is, already I wrote this one. Here this can be written as here even value. Even value is what? Again we know this one. Even value we got the q by 4 pi epsilon naught AP square value, or sorry, E1 is equal to q by 4 pi epsilon naught r square plus l square. So simply substituting the value of E1 into this equation, then I can write q by 4 pi epsilon naught r square l square dot this 2l is as it is, r square plus l square to the power of half. Okay, so here already I told you AB value is here, this AB value is 2L only. Okay, so I wrote 2L, so that is 2L. Now we know that according to the this term, that is electric dipole moment is nothing but it's a product of magnitude of the one of the charge and the distance between the two charges, that is nothing but a P. So I can replace this Q into 2L as P. So that's why E is equal to P by 4 pi epsilon naught r square l square, and this is to the power of half and this is to the power of 1. It means that is to the power of 3 by 2. So we know that this r is very small, very much greater than L. So here R value is very large compared to the L. Then if you take the L square, this is very smaller. L square is still smaller than the R. So that's why we can neglect the L square. Okay. So we can write E is equal to P by 4 pi epsilon naught dot R by 1 by R cube. I can write. This is we are neglecting. So this is the expression for the intensity of an electric field at any point on the perpendicular bisector of an electric dipole. Thank you. For more videos, subscribe my channel Physics.